As a physicist, something which you will be confronted with on a regular basis is error analysis. There are many techniques used in this wide-ranging subject, too many for this video, so we will simply outline a few of the main concepts required when performing error analysis in MATLAB. These are importing data and analysis. You may have collected your data via a different program or instrument. You may even have written results down with a pen. Either way, you need to get it into MATLAB. If the information is stored in a file on your computer, then you can simply use the import wizard which you will find at the top of the interface. This allows you to locate the file anywhere on your computer and open it. You can specify exactly what data you want to import and any variable names. After importing, the data will be saved in the workspace under those names. This can all be done directly from the command window. Reading in requires a function which reads the particular file type you are dealing with and the path of the file. The term path means a full description of where the file is stored on the computer. For example, this is the path of the folder MATLAB on the local disk. Note that the format of the file is also important because there are many different functions which are designed to read different file formats. For most images, the function imread will suffice. It reads the image data into an array of numbers which MATLAB will understand and you, as the programmer, can manipulate. Note that we are using the full path here. Since it's a string, you have to use inverted commas and specify the format of the file. To print the image, use the image function. If you have a certain file format which you do not know how to read in, then we recommend consulting the MathWorks website. Once you have your reading in function, the easiest way to get the file to save to the workspace is to make sure that the file is located in the current folder. Then you only need to input the file name into the function. However, if the file is not in the current folder, then you will have to use the full path of the file as described earlier. If you import data during one of your own functions in this way, then you could use it in any directory, making the program more flexible. Let's go back and import our own data using the direct commands. Here are three normal distributions saved in Excel. MATLAB has a specific function for Excel files, and that is xlsread, which works like this. Notice that we only need to use the file name since data.xlsx is already in the directory. This will save to the workspace, but it will simply save as ants, so we will give it the variable name d for data. We also had the column vectors x, y, and z, which we can define again by indexing the columns as shown previously. X as the rows in column 1, Y as the rows in column 2, and Z as the rows of column 3.
The variable d is now in the workspace, and we can plot it with the plot command. But if this were real data, then we would want error bars as well. Let's say the error in measurement was plus or minus 1. Error bar is the function for plotting a graph with error bars. The inputs are two arrays you want to plot on the axis and also the upper and lower limits of the error bars. Be careful here, you cannot simply type the value of the error into this function. MATLAB works in arrays, so that the upper and lower limits must be applied to each point in the data. If the upper and lower limits on all our points are the same, then MATLAB will recognise the error bar command with only 3 inputs where the third is an array of the error. Understand? Well, maybe an example will make things clearer. To carry out our plot, we need an independent variable t and our error value. The length function gives the number of elements in a vector. We have said before that the error in this case is plus or minus 1. An easy way to create this would be to use the ones function. This will give a matrix of ones that is the same size as our D array. Now we are ready to use the error bar function. So the first two entries are the x and y axis, and the next one is the value of upper and lower limits which we have set. Error bars are a useful tool if you have a trend to which you're trying to fit some data. Generally, the best fit line should pass through these errors. Another useful graph in data analysis is the histogram, the command for which is hist. If you just plot hist with the data series, then it will automatically categorise into 10 bins. The bin number can be specified as well, with a scalar like this. MATLAB also has a wealth of other functions and statistical operations such as finding the mean, standard deviation, and correlation coefficients. As mentioned at the beginning of this video, there are many more options for analysis with MATLAB which you should try to incorporate into your analysis procedures. Let's continue practicing by taking the variable y from earlier, and instead of plotting uniform errors, we'll say that the error on each point is plus or minus 10% of the actual value. In this script, we have imported the same data and categorized it in the same way, but now the error bars are no longer uniform. To get our 10% error, we have multiplied the values of y by 0.1. So far in this series, we have introduced the basics of how to use MATLAB for simple operations, but it comes into its own when you start programming. This will be the subject of subsequent tutorials, taking a problem in real life and turning it into a program.